More flash flooding, damaging winds up to 60 miles per hour, isolated hail, and maybe even a tornado. Good morning, I'm meteorologist Pew. Today is July 26, 2025. In terms of flash flooding, the Weather Prediction Center has issued a slight risk or a 2 out of 4 again for the Midwest, but also in Pennsylvania today. In the next 24 hours, places in the Midwest, Great Lakes to the Mid-Atlantic are going to see rainfall totals from 1 to 2 inches, and in isolated places, especially around the Great Lakes, are going to see maybe 4 inches. For the time frames, places like Iowa and Northern Illinois are already seeing convection from this morning, but that's going to slowly start dissipating. But a second round of storms are going to start initiating around 19Z or 2 p.m. Central Time, and that's going to travel northeast. And for other places in the marginal risk areas from the Great Lakes to the Mid-Atlantic, we also are going to see something in 19Z, and that's 3 p.m. Eastern Time. And then for the northern plains, it looks like things are going to start a little bit later at 22Z or 5 p.m. Central Time or 4 p.m. Mountain Time. And some of these storms are going to last throughout the night as well. Looking at 500 millibars or midway through the troposphere, we're going to have 2 shortwave troughs, one in Utah and one in the Midwest. Looking at the shortwave trough in Utah, it's pretty well defined, and it's going to travel northeast. And it's going to do 3 things for the storms. First, it's going to bring in cold air aloft, and what that's going to do is when the air particles rise, colder it is aloft, the faster this air particle is going to rise. Second, it's going to bring in good wind speed, which is going to give us good shear, and it's going to tilt those updrafts and prolong the storms that do develop. And the third thing it's going to do is because the winds aloft somewhat go parallel to the isobars, these little curvatures or these little nicks are going to make the wind barbs just spin a little bit, and that's going to add vorticity, which is going to add more spin to the updraft, which is going to enhance it, but it also is going to promote more upward motion. Taking a look at satellite imagery, we can see that we have clear skies in the northern plains, and this is going to provide diurnal heating, more surface heating, and basically add more instability. But if we take a look at the Great Lakes region, we can see a lot of clouds, and that's going to prevent the diurnal heating. But also there's a lot of convection in this area, so this precipitation is going to make this area cooler. Though in addition to that, south of that area, we're going to have clear skies, and that's going to give us diurnal heating and that surface heating. And if we look at the surface, we're going to have a high pressure in the southeast, and for high pressure, winds flow clockwise, and so we're going to have winds coming from the south to the north. And so the Great Lakes region is also going to get provided with the warm, humid air. So in combination with the cool air and the warm air interacting with each other is explaining why we have a stationary front and the constant convection. Now going to the northern plains, we're going to have a surface low somewhere in Wyoming, and it's going to deepen, which is going to increase the pressure gradient, which thus is going to increase the surface winds. And as these surface winds get stronger, they're actually going to turn to the northwest. And this is going to be significant because in this area, the terrain gets a lot higher. So what's going to happen is what we call orographic lift, or basically surface winds being forced upward because of the terrain itself. And west of the low, we're going to have the opposite effect, where the winds are going to be coming from the west and going to go downslope of the mountains. So from the east side, we're going to have warm, moist air, and from the west side, we're going to have warm, dry air, and that's going to form that dry line and produce those surface lifts to help initiate those storms. And on top of all that, we're going to have a cold front coming from Montana and North Dakota. It's going to travel south, and that's going to provide even more surface lift. And that's why we have